Hello and welcome to the Architecture Refactoring Techniques segment of this video. In this segment, we'll be looking at both technical as well as non-technical aspects of architecture refactoring. So in the first Software Architecture Fundamentals video, we talked about the roles and responsibilities as well as expectations of an architect. One of those roles and responsibilities and expectations was for the architect to analyze the current technology environment and recommend solutions for improvement. Now this includes all aspects of the project lifecycle, including development, testing, configuration management, as well as release management. What you're really doing here is assessing what's called architecture vitality. And this is really assessing the state of the architecture. Is it still viable? Is it still able to sustain the application and future needs and functionality? So let's say as an architect, you do this exercise and you start observing the following. For example, the application builds fail almost every time something is committed to the repository. And this, by the way, didn't used to happen before. Every time the application is deployed with new functionality, something else usually seems to break. You also start observing as the architect that application deployments seem to be taking a long time, lasting up to 25 minutes. And lastly, you're noticing an increase in performance issues reported by the users with the application. And here's the usual result from these observations. You as the architect, and here is the manager, and you say, things are getting really bad. I think we may need to make major changes to the architecture. And of course, the usual response, no. We'll never get funding for that sort of thing. Just try to plug the holes as best you can. So the point here is it's really difficult to get the business to pay for architecture refactoring efforts, primarily because they see this as a technical issue, not a business one. So the trick as an architect is basically to turn these technical issues into business issues and create a case to justify the cost and effort for the refactoring effort. So the main key point here is that architecture refactoring is more than just a technical task. It's about justifying your decisions, creating a case, and presenting your ideas in a well-thought-out plan. So let's take a look at the steps involved with architecture refactoring. And what we're going to do is take really a deep dive into each of these steps. So if you look at the screen here, you'll notice the flow. The first step here is to determine the architectural root cause of each issue. In other words, you're asking the question, is the root cause an architecture one? Is it architecturally related or is it more of a technical issue? Okay. Then, if it is an architecture related issue, what changes can we make in the architecture to actually resolve this issue? Okay, and that's the second step. This is really determining what the end state of the architecture will be to be able to fix some of the issues that we're seeing on the project architecturally. Okay. This leads to the third step, which is really to create a business case justifying those changes. Now, in a lot of cases, this step will not be executed. A lot of architects will end with determining what those changes are needed and start implementing those straight away. However, what we want to do is to be able to create a business case to justify those. So really what we're asking in this is, how does this change benefit the business? Does it even benefit the businesses, or is this purely a technical change? What is the business value of these changes? Those are the things we're answering in this step. Then we move on to actually part of the fun piece, which is developing a high-level architecture refactoring plan. And we'll be spending quite a bit of time in this segment on this one piece right here. So once we devise a plan of the number of iterations, the type of iterations, and how that architecture is going to look all across the refactoring effort, we then move on to creating a timeline containing estimates and resources. This is actually an important step. We're going to dive into this in a little more detail as well. Finally, the last and probably the most difficult and scariest part of architecture refactoring is then presenting your case and plan to the business for funding and approval. Okay. So let's start with the first step, determining the root cause. So let's take a look at each of these fictitious issues and see if we can see architecturally, is there any concern? So the application builds failed almost every time something is committed to the repository. And what you noticed architecturally is that A, the application components are really too tightly coupled and dependent on one another. And also you recognize that the application components that are currently in place have grown due to additional functionality and don't have the right level of granularity and isolation from a roles and responsibilities standpoint anymore. Okay. So we look at the second issue. Every time the application is deployed with new functionality, something else usually breaks. Okay. Fairly typical in large monolithic applications, and you observe the same two conditions as well. Components are too tightly coupled, and they don't have the right level of granularity and isolation anymore. Let's look at the third issue. Application deployments take a long time, sometimes lasting up to 25 minutes. Now, this wasn't usually the case, but you kind of just started observing that it's been increasingly taking a long time to deploy. And you realize that the application is monolithic and it's growing quickly based on new features and functionality. So essentially, you surmise that it's just getting too large for a single application. Okay, so architecturally, there is kind of a concern about the deployments. And what about that last one? Users are increasingly reporting performance issues within the application. Well, you do some metrics and you find out the application is becoming simply too large. It's consuming, as a monolithic application, about 95% of the available JVM resources during normal load. And this includes such things as memory, CPU, threads, etc. Okay. So in determining the root cause, you look at your issues. Some of them may be technical, some may be architectural, but you come up with a root cause summary, which essentially is this, that the application is becoming too tightly coupled and quite simply is growing beyond what the current architecture can support. Okay. But here's the point. You still can't sell it to the business at this point. Okay? The business is going to have no idea what tightly coupled means and its effect on the application or the business as a whole. Furthermore, if you presented your case at this point, what you're going to get is the fact that the business doesn't understand why the architecture can't support a larger application. What do you mean? Can't we just buy more memory or more servers? And these are the questions that will essentially squash a whole architecture refactoring effort. So the next step is to identify the problems, which we have. And the next step is to determine the corresponding architecture changes that are needed. So this is really where your technical knowledge and business knowledge of the architecture comes in to say, we are currently here, for example, the monolithic application is too tightly coupled and is growing beyond what the current architecture can support. What you lean towards is saying, well, if I were to be able to decouple this application and really split it up into multiple pieces and multiple deployable units, I can decouple components and then I can allow for the potential growth, some additional growth. So here we have currently defined an end state of the architecture. We want to move from a monolithic to start splitting up the application into multiple pieces. Okay. Note that this, by the way, is a rather extreme example. Yours may not be as drastic, but it does indicate clearly here the changes that you can actually do within an architecture to resolve certain issues. Okay, so we don't stop there. We can create a business justification because we know this is going to be fairly costly. And we also know it's really hard to sell architecture refactoring efforts to the business. However, if we can supply some business justification, then we can sell it. And so let's move on to that third step, justifying your case. Okay. There's two parts of justification here. There's a technical justification as well as a business justification. Let's take a look at the technical justification first. This is usually easier to do than the business one, but let's tackle this. So really what we'd like to do in this refactoring effort is to split the monolithic application into multiple deployable units, thereby decoupling components. So the technical justification or advantages that we get here, I should say the technical value really, is that components will be more decoupled, thereby eliminating these frequent build issues. So by doing this architecture refactoring effort, we can remove those build issues that we're currently having. Each part of the application will definitely be smaller. It will use fewer parts of the JVM resources, and thereby increasing performance and also allowing for more growth. And deployment will be limited to these separate application units, so therefore it's going to reduce the deployment time and increase the overall robustness, which really, robustness being the fact that one small change impacts other areas of the application. But at this point, we still can't sell this effort as an architect. Why? Because the business is not going to understand what decoupled is, or JVM resources and all these. So the next step is to build a business justification for this. And let's do this with the following. For example, with these changes, new functionality can actually be delivered faster to the market. Therefore, we can actually improve the overall time to market. Secondly, by making these changes and undergoing this architecture refactoring effort, the overall application quality will be improved, thereby reducing bugs and the associated costs on fixing them. And kind of thirdly, the development and deployment costs will be significantly reduced for adding new functionality. So as you can kind of see, when you're selling it to the business, selling this case to the business, really it boils down to things like time to market, costs, return on investment, these sort of attributes. And clearly here we can actually demonstrate those through these changes. At this point, oftentimes it's also good to accompany these sort of things with an architecture risk assessment. So really it's kind of turning things around the other way. Instead of saying what good things will occur, it's saying what bad things will happen if you don't implement these changes. And business folks and managers really like things in terms of risk because it helps them prioritize and get a sense of urgency for these sort of things. So sometimes it's actually good to include that risk assessment in addition to these sort of justifications. So the fourth step in the process is the refactoring techniques. This is building out a plan. Okay? And this is, I guess, probably the funnest part of these 6 steps. But essentially there's 4 main tips here. The first is quite simply to work in small iterations. And also in each iteration, be sure to identify or be able to identify the technical and business value expected. Now, 2 techniques that I typically use, which are very successful, are to use a playbook approach to outline the architecture transformations, and then finally decide on which components are going to be either migration or adaptation refactoring, or even a combination of both. So let's go over what each of those 2 mean. Okay, so in the playbook approach, essentially this is where each iteration should be clearly illustrated and the changes to each architecture clearly illustrated each step along the way. So for example, you illustrate clearly the current state of the architecture, what it's going to look like after the first iteration, the second iteration, and finally iteration 3, which would be the final step. As a matter of fact, you can go as far, this is kind of boring, you can actually go as far as to name your iterations to be able to give it context. So iteration 1 might be named, for example, UI backend split, for example, just to really give it some context. Okay. Now, within the playbook approach, so a couple of things. First, you definitely want to identify the purpose behind each of these iterations. And secondly, to be able to identify the business and technical value achieved at each step along the way in each iteration. Now, one of the tips is to try to minimize what I call staging iterations. You probably will have some of these. A staging iteration is an iteration in your playbook that really does not have any business value associated with it. In other words, let's say that we're going to split up the application, like in this case, and what we want to do is to set up a messaging infrastructure within our environment because we don't currently have one. This would be a separate iteration so that everything is set up to be able to start migrating components. That's a good example of what would be called a staging iteration. There's no business value. There's a little bit of technical value, which is we get our messaging infrastructure in place, for example, but there's no business value associated with that. So it's good to identify a staging iteration because it will have to be funded and there's not going to be any perceived value that's coming from that piece. And fourthly, try to keep the iterations as small as possible while still providing enough technical and business value. And really what we're talking about here is reducing risk and minimizing the disruptions to either existing projects or the application as a whole. Don't be afraid to have as many iterations as you need. In other words, in very, very large architecture refactoring efforts, it's not uncommon to have maybe 10 or 12 different iterations. Smaller ones maybe only have 3 or 4. So when you're refactoring or replacing components, there's 2 techniques that you can use, and typically you'll form a hybrid of combination of these, but it's migration versus adaptation. So migration is creating new components and migrating functionality over to those, whereas adaptation is really refactoring existing components to conform to the new design. So let's say we have 2 components here. Component 1, which I'll label C1, which we're going to keep, but component 2, which I'll label C2, which is deemed to be refactored or replaced. The idea of the migration technique really is to replace old components with new ones through migration over time. So C2 is then marked for replacement, as you can see here. Now, if you watch the graphics here, you'll notice that we create the new component. I'm going to call this C3. It's brand new. And we're actually going to have component 1 be able to talk to C3, whether that's through some sort of remote access or just even a tight binding. Then what we do is we start migrating functionality from C2 over to C3 until it's finally fully migrated, and then C2 completely goes away and we have our new end state. So if we look at the technique of migration, first of all, it definitely is easier to roll back changes in this particular approach because component 2 still has the old functionality. So if something doesn't work in component 3, we can always switch back and use component 2 very, very quickly because we haven't really removed it. It's just been migrated. There's less overall risk because of this. However, there is a situation where some of the components may have to have switching logic. For example, C1, which is indicated here, has to know whether I go to C2 or C3 for that particular functionality. So that's migration. Adaptation, on the other hand, which we'll take a look at here, is where we have the same setup. Component 1, C1, we're going to keep. C2, we're going to refactor or replace. Adaptation really is talking about refactoring of existing components into the new functionality. So in other words, instead of creating new components, we're going to refactor C2 over time in place. So C2 starts actually morphing into its end state in place, thereby having the end state right here. So some of the aspects of adaptation is it's a refactor versus a replacement. Instead of migrating functionality over to a new component, this is actually changing an existing component over to some sort of end state. It's harder to roll back changes in this case. However, there's less components affected in the calling components because we don't have this switching logic in place. So as an architect, when you're forming your plan of iterations, it's not enough just to say, here's my playbook approach with all of the iteration steps, but also, how am I going to get from the current state to iteration 1? How am I going to get from 1 to 2? And that involves either a migration or adaptation of components. Okay, let's look at the 5th step, which is creating a timeline. So when we create a timeline, one of the things we're going to have to add to our business plan, or our case, I should say, for architecture refactoring, is how long is this going to take and how much is this going to cost me? Now, a lot of times as an architect, we certainly don't have maybe the internal costs associated with it, but we certainly can estimate the duration of each iteration and an estimate of how many resources are going to be there. So I tend to like to put together some sort of graphic that shows kind of a rubber banding of each iteration step to kind of illustrate the length. In other words, iteration 4 is going to take longer than 1, 2, and 3 in this case. Kind of a short description of really what the purpose of that iteration is, the duration, the number of resources, and give it sort of kind of a visual timeline for management and also the business to be able to see. Now, this is also a really good place to start thinking about metrics. So in other words, we're promising after iteration 2 that we're going to see an increase in performance. It would be nice if we were able to actually measure what sort of increase we got. In other words, what was the business value after iteration 2 in this example here? What we can do is establish benchmarks early on in terms of performance, time to market, costs associated with implementing new functionality, and after each iteration, run through those benchmarks or those metrics again to say, wow, we just received a 25% increase in overall performance and we're delivering functionality 2 weeks earlier than we did before. Okay, so that's also another good thing to add to this particular segment right here. Okay, so the final step in the process is presenting your case. And this is perhaps one of the most difficult steps in this whole process. Even though these folks are smiling, as you can see here, they're about to eat you for lunch. And this is what makes presenting your case so scary. But don't worry. If you're confident in your architecture decisions and your plan, you'll do just fine. Okay. So let's go over some tips and techniques to kind of help you present your case effectively. The first of those tips is to anticipate this particular question before you go into your meeting. And this is this question about how did things get this bad in the first place? And invariably this will appear. And the first tip here is really don't place the blame or throw anybody under the bus, because unfortunately, ultimately, as the architect, you should have been proactive in the first place in terms of identifying these issues. So if anybody's to blame, it's probably the architect. So there's two ways you can actually divert this particular question. The first way is to launch into a discussion about have more proactive monitoring tooling capabilities and try to get funding for those as kind of a tangent in this whole case. But quite simply, in this particular example, the answer to this question is fairly easy. And it's the fact that the architecture was well suited for the application when it first started, but it has grown with additional functionality over and above what we originally anticipated, and it's not sustainable anymore. So how did it get so bad? Because we've continued to add functionality over time.
And this is a really important point, the how did it get this bad in the first place question, because architects dread this question because they assume that the people who are asking this question are assuming incompetence on the part of the architect. And a lot of times that's not the case. A lot of times it was things out of their control, like growing scope or scale of the project, or decisions that were perfectly valid 2 years ago that because of external factors have become invalid now. So don't be afraid of this question. Like Mark said, have a good list of reasons why this happened. That doesn't include that I was incompetent, because hopefully you weren't incompetent.
Exactly. Okay, good. All right, the second tip here is really on presenting your case is always make sure that you present your plan to your immediate manager before going to the business. And this is quite obvious, but the reason I bring this up is because this is somewhat of a touchy area and requires a little bit of politics, I guess you would say. So depending on your situation, your immediate manager may not feel even going through these 6 steps is even worthwhile. And in that case, if you approach your manager too early, they may say, yeah, you know what, we don't have time for this. There's too many emergencies to do. I don't want you working on this kind of effort. In which case, the whole architecture refactoring process just completely falls apart. So part of this trick is identifying that kind of situation that you're in. And if you are in that situation, it's much better to go through all of these steps first, at least up to step 5, creating a timeline, then present it to your immediate manager and say, hey, we've got some serious issues with the architecture. Here's those issues. Here's what we can solve. Here's the business justification and the technical justification for it. Here's my plan of being able to iterate it, and here's how much it will cost. Then you can sit down with the manager. Alternatively, if you've got a manager that's really willing to sponsor you, you can actually work through all 6 of these steps with that manager. But the key point here is never go over your manager's head directly and go straight to their boss or the business. Have your manager or your immediate manager as your sponsor, because it makes them look bad, it makes them feel like they don't know what's going on, and that's just not going to be healthy for your career. Okay. The next tip, quite simply, is not to scare people. So the quote I like to use is, present with urgency, but not with panic. Okay? So in this case, you want to be able to effectively present that we're starting to have trouble, but that the sky necessarily isn't falling. This is where the risk assessment I talked about before can become very, very useful, because it really helps prioritize the aspects or the areas of the architecture that may need to be fixed first. And finally, the last tip is really, although you may know all the answers and you've well thought out this plan, don't be argumentative. So take the opportunity to educate the business instead of arguing with them in terms of why this is needed.
And in an upcoming chapter, I will talk about some techniques using tools like Keynote and PowerPoint for the physical manifestation of how you present your case.
So to kind of summarize some of the points here in this particular segment, first of all, know that refactoring is very expensive, and it's difficult to get the business to pay for architecture refactoring efforts. And this is a huge challenge, probably the #1 biggest challenge in tackling architecture refactoring efforts. So know that architecture refactoring is also more than just a technical task. It's about creating a proper case and selling your ideas. And this is where really the soft skills of architecture really pay off. Technically, you know exactly how to get to point A to point Z. But that's about 1/6 of what we saw the issues or the process was here. And always remember every step along the way to be able to identify the business value associated with the refactoring effort, to be able to justify the cost, because these are expensive. And finally, be proactive in assessing architecture vitality, because certainly smaller architecture refactoring efforts are easier to sell than bigger ones. And remember that question about how did things get so bad, it's going to be a lot easier to answer if we've got 6 months to change the architecture than 2 months. All right, so this has been the Architecture Refactoring segment of the video, and thanks for watching.